To produce more accurate diagrams, draw your circles first and then add in the other information. Here is the circle with center O1, and this is our point P on the diagonal of the square. This will be circle 2. I'll draw it separately so that our diagram doesn't get too cluttered. It's also going to intersect the diagonal at point P. I'm going to draw a third circle. It's going to pass through vertices A and D, and it'll have center O3. Notice that circle 1 and circle 3 are symmetric about the diagonal AC, so it's also going to pass through the same point P. And we have that the angles O3PA is going to be the same as the angle O1PA. O1 and O3 are right on opposite sides of this diagonal. Let's take a closer look at circle number 3. We have A and D over here, and it passes through this point P. O3 is the center of our circle, so this is a central angle. This is 45 degrees up here. So our central angle PO3D is 90 degrees. And then if we look at circle 2, which passes through D, C, and P, this angle down here is also 45 degrees, and it's an inscribed angle. The corresponding central angle, DO2P, then is twice that, or 90 degrees. Two of our radii up here of our circle 3 are O3P and O3D. We also have two radii in circle 2, O2P and O2D. We'll draw our quadrilateral that consists of O3, D, P, and O2. We have right angles at these opposite vertices and adjacent congruent sides, which makes this a square. So when I draw this diagonal DP, I have that the angles above and below the diagonal, O2PD and O3PD, these are congruent at 45 degrees. Let's call them Y for now. Let's place this red square back in our original diagram. Here's our original square ABCD and its diagonal with P. These are our congruent angles Y. Here's O1 on the other side of the diagonal, and we showed earlier that these two angles were congruent, O2PA and O3PA. So in terms of X and Y, angle DPA is X plus Y. We're given in the problem statement that the angle between O1P and O2 is 120 degrees. That is 2X plus 2y, which means x plus y, or angle DPA, is 60 degrees. Let's redraw triangle ADP. AP was part of the diagonal, so this is 45 degrees, this is 60 degrees. AD is the side of the square, that was length 12 from the problem statement, and we're interested in the length of AP. I'll draw this altitude. We have a 45-45 triangle, so the distance from A to E is 6 root 2. I'll write that as the square root of 72. And the distance from E to P is 6 root 2 over root 3, and this simplifies to root 24. So now we can find the distance from A to P. It's AE plus EP. That's root 72 plus root 24. The problem asks for A plus B, and our answer is 96. If you'd like me to solve any other math contest problems, please leave them in the comments.